What really happens in the heart of galaxies? Imagine observing a cosmic feast, a gigantic meal where the most mysterious and powerful forces in the universe feed in ways that challenge our understanding. For years, scientists have sought to understand the behavior of supermassive black holes, the enigmatic giants that reside at the center of galaxies. But recently, a surprising detail has emerged. These cosmic monsters do not instantly devour everything that comes near them. Instead, it appears that black holes prepare their food, slowing down and managing the assimilation of surrounding matter in a remarkable way. For centuries, the idea that black holes simply swallow everything that approaches them without pause or control has been a dominant concept. However, the latest observations have started to dismantle this idea. Thanks to the most advanced telescopes of our time, such as the Chandra Space Telescope and the Very Large Telescope, astronomers have gathered crucial data showing that black holes do not indiscriminately suck in everything around them. Instead, they appear to regulate and manage the entire process in ways that still elude us. One could imagine a cosmic banquet in which the black hole performs a preparation ritual before consuming its prey. A fascinating phenomenon in this regard is the formation of enormous accretion disks around black holes. These disks are composed of gas and dust that orbit the black hole, heating up until they become incandescent, emitting high-energy radiation. This gas can become so hot that it emits X-rays, which are visible thanks to space observatories. However, observing these disks is not as simple as it may seem. Rather than a simple meal, scientists have discovered that these disks rotate chaotically, and often the particles within them are not merely devoured. Instead, they cool down and are blown away by the black hole, a process that can be compared to a kind of food management. Near supermassive black holes, enormous jets of particles and radiation also form. These jets are so powerful that they influence not only the black hole itself, but also the entire galaxy that hosts it. The matter that is not immediately swallowed is expelled in the form of radiation, creating real energy explosions that can last thousands of years. Black holes, therefore, are not just passive consumers of matter, but dynamic cosmic actors capable of profoundly altering the structure of the surrounding galaxy. When the jets of particles emerge from black holes and strike the hot gas permeating intergalactic space, they carve out large cavities in the intracluster plasma. These cavities are enormous, and they result from the incredible forces released during the jet explosions. What is fascinating is that when these jets interact with hot gas, they generate a series of filaments that cool and condense into colder matter. This cold gas not only helps cool down the surrounding area, but is also drawn back toward the black hole. The process, at its core, is a cycle that continuously fuels the black hole. In a way, it can be seen as a kind of nourishment source that allows black holes to keep growing and evolving. This phenomenon has been analyzed in detail by observing numerous galaxy clusters, cosmic structures that contain some of the most massive galaxies in the universe. In each cluster, the supermassive black hole at its center is not an isolated entity, but acts as a pulsating heart that influences the behavior of the entire galaxy. When astronomers examined these clusters, they discovered that the gas surrounding the black hole behaves like a fluid flowing through a complex system of communicating vessels. The black hole's influence on this gas is never simple or direct. Rather, it is a continuous process that mixes and redistributes matter, some of it being expelled while another portion is drawn in to fuel the black hole. The colder gas that accumulates and falls toward the black hole becomes fuel that nourishes it, creating a cycle that could last billions of years. This discovery has profoundly impacted our understanding of the role of black holes in the universe. Until recently, black holes were seen merely as matter destroyers. Now, they are viewed as dynamic entities that play a fundamental role in the evolution of galaxies. They do not just destroy, they also contribute to the creation of new stars, acting as cradles of cosmic birth. When cold gas is drawn into a black hole, it is not simply annihilated. Many times, this cold gas can condense into stars, giving rise to new worlds and new galaxies. In effect, a black hole is not just a monster that devours matter, but also a cosmic forge that helps regenerate and renew the universe. Moreover, one of the most intriguing aspects of this new understanding is the comparison with other galactic phenomena. Medusa galaxies, for instance, are galaxies that travel through the intracluster medium, an ocean of hot gas located between galaxies. This hot gas is stripped away from the galaxy itself, forming long trails of gas that extend behind them. These trails are similar to the filaments that form around black holes, suggesting that the interaction between gas and galaxies is far more dynamic than we previously thought. In a sense, these interactions show that galaxies and black holes are not static, separate entities, but are part of a complex system of forces that shape and mold the universe. Yet black holes continue to surprise us. Many galaxies, including our own Milky Way, host supermassive black holes that have seemed dormant for millennia. These black holes show no apparent activity and do not emit significant radiation. Until now, scientists have thought that these black holes were inactive. However, surprisingly, observations suggest that even seemingly dormant black holes can suddenly awaken in spectacular events that challenge our understanding. In 2019, astronomers witnessed an extraordinary phenomenon coming from a galaxy about 300 million light-years away. This galaxy, located in the Virgo constellation, began to emit an unexpected and astonishingly bright light, much more intense than ever observed before. Scientists were unable to explain the phenomenon, as there were no signs of a supernova or stellar explosion. Instead, it seemed that the center of the galaxy had started to emit enormous amounts of energy, suggesting that its black hole had suddenly awakened. This awakening may have been triggered by the onset of an accretion process, during which the black hole began feeding on surrounding gas and dust. This scenario could explain why, after a period of dormancy, black holes can resume their activity with devastating power, altering the entire balance of their host galaxy. This discovery has enormous implications for our future, as it suggests that even our galaxy, the Milky Way, could witness a similar event. The black hole at the center of our galaxy, Sagittarius A, has been dormant for millions of years. However, if a sudden change were to occur, similar to what was observed in the Virgo galaxy, our black hole could awaken, triggering an explosion of energy that might illuminate the entire sky. This awakening could transform our night sky, offering an extraordinary view never seen before. All of this leads us to an important question. How much do we really know about black holes? Their nature, their behavior, their role in the evolution of the universe, these are questions that never cease to amaze us. They are mysterious and powerful entities, capable of managing, consuming, but also creating. Each new discovery brings us closer to a deeper understanding of these enigmatic cosmic giants. But how much remains to be uncovered? And what other surprises do the dark giants hidden at the heart of galaxies have in store for us? Thank you for watching. Leave a like and subscribe to the channel so you don't miss upcoming videos.